So we are continuing from where we stop. Since there is no rule for addition of power, don't forget that I told you that addition covers two things: adding a positive quantity, and you can also add a negative quantity. And since there was no rule for adding variables, there is no rule also for subtracting variables. Note, x minus y can be written as x plus minus y. Minus y is the negative quantity we are adding. So that's why I told you that addition covers subtraction. See that? So there's no also rule for subtracting powers also, because the nth power of a is undeterminable. I'm not subtracting the nth power of a from it. Also, the nth power of a is undeterminable. So this result altogether is undeterminable. We cannot get the results. So there's no rule for the subtraction of power, as there is no rule for the addition of power. I think this is clear. Now let's go to the division of powers. The division of power, rule for dividing powers. Rules for dividing powers. Now let's start now. Consider this: a raised power 3 divided by a raised power 2. In ordinary form, it can be written as a raised power 3 over a raised power 2. And by definition, the third power of a is written as a times a times a. And the second power of a is a times a. Take note, I said a raised to power 3. It is a that is raised to the power 3. Power is a product, don't forget. So I call it a raised to the power 3. So it's either I say a raised to the power 3 or the third power of a, that the same thing. So don't let that confuse it, at the same terms. Now by this, since this is multiplication, we can equally divide. A divide a will give us 1. 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 So we have 1 times a, which will result in a. 1 times 1, which will result in 1. And any number divided by 1 is that number. And this a can be written as the first power of a. So this one we have here, this index 1, it looks as if we subtracted 2 from 3. That is, we have something like in this nature, the 3 minus 2's power of a, something like this, because 3 minus 2 is 1. But you would think that it's by mistake. Because of that, we have to consider further example to verify what we want to generalize. Again, consider a raised power 5 divided by a raised power 2. And this can be equally written as a raised power 5 over a raised power 2, which is equal to, by definition, a times a times a times a times a over a times a. The a here 1, a here 1, a here 1, a here 1. So we are left with 1 times a times a, which will give us a times a times a. 1 times 1 will give us 1. And any number divided by 1 is that number, a times a times a. Now this is interpreted as the third power of a. So again, this index 3 is as if we subtracted this 2 from this 5. That is, we have 5 minus 3rd power of a. So this is not by accident. Again, it's becoming clear that it's true, universally true. So we can generalize. We can say in general, a raised power m, or the nth power of a, divided by the nth power of a is equals to the m minus nth power of a. So this is now a rule. We can also extend it. We can extend it in the situation whereby we have the nth power of a divided by the nth power of a divided by the zth power of a. It can be divided by so. That is the same. That is the base are the same, but a different power. So it become m minus z minus so power of a. So this is an extension. So we stop here for the moment. If you are interested, you click on the subscriber on red to get more of this video.